Alright, this is Math 122. This is homework 4. And I'm now going to show you how to do part 2 of problem 1. We did part 1 already, where we input -1 for the value in place of x. And when we did the function of -1, we came up with the answer 6. Now we're going to input the value t plus 1 into the function. So again, this is problem 1, part 2. We're going to be finding f of t plus 1. Putting t plus 1 into the function f of x equals 3x squared minus 2x plus 1. So how do we go about this? Wherever there's an x, we're going to replace it with a pocket. Let's start with our placeholder on this side, telling ourselves what we're going to be putting into the function in place of x. Let's get the right side ready. 3 with a nice big pocket, because we're going to be putting more than just a single value in there. The exponent, which was outside of the x, minus 2, another pocket where x was here. I've got a pocket now, and the plus 1. What are we putting in the pocket? T plus 1. A little strange, because it's not just a numeral like we did in part 1. And this gets a little bit tricky because we've got to do some foiling to simplify this equation, this function now. So right here we've got t plus 1 squared. What you have to remember is what that means is t plus 1 times itself, 2 of this base multiplied. So I'd like you to rewrite it like this: t plus 1 times itself. And then bring down the minus 2 times the quantity t plus 1 plus 1. Just bring down the rest of the function. Because now we're going to deal with this little mess here. If you remember from week 1, you learned how to FOIL. You can either use the box method, or we can just FOIL this out. The t wants to get multiplied by the t there. And let's go ahead and start doing that. Notice the 3 is still outside. We cannot multiply that yet until we've taken care of the exponent. So 3, let's make a big parentheses here. T times t is t squared. There's our firsts. Now we multiply the outers. T times 1 is 1t, and it's positive, so let's go plus 1t. Now let's do the inners. 1 times t plus 1t, and then the last, 1 times 1. It's positive, so we're going to say plus 1. Now keep working vertically. Bring down the rest of the function intact, because you haven't operated on it yet. Now the next thing we need to do is distribute. This 3 outside the parentheses wants to get multiplied by, oh, wait a second. Hang on a second. We can actually do a little bit of simplifying first. 1t and 1t can get combined to make 2t. Let's do that first, then we'll have fewer terms that we're going to have to multiply through. Alright, now we're going to distribute the 3 and multiply it by everybody inside. Again, all I just did was add the 1t and 1t together because they're like terms. Alright, 3 wants to get multiplied by everybody inside. There's no subtraction or addition symbol between the 3 and the parentheses, so that means multiply. 3t squared plus 3 times 2 is 6t, plus 3 times 1 is 3. Now I don't need the parentheses anymore. Now the next binomial has a 2 outside of it, and we're going to think of this as a -2. I'm actually going to change this to add the opposite. It's going to be easier to think about this problem this way as we're multiplying through the binomial. So I'm going to go add -2 times t is -2t. -2 times 1 is -2, or plus a -2. And then don't forget our little plus 1 hanging here on the end. Just a few steps left, and we'll have this simplified. Now we're going to combine any like terms. So I'm going to take a look at the first term, 3t squared. Any other t squareds? Nope. So 3t squared is going to stand alone, not get combined with anybody. Now let's take a look at the 6t. I've got a 6t, positive. I got a -2t. Any other t's? Nope. Add the 6t and the -2t, and I get a positive, or plus 4t. And last but not least, we've got a 3 minus 2, which is 1, plus 1, which is 2. So 3t squared plus 4t plus 2. And that is as simple as it gets. There's no more like terms that we can combine. So what did we do? We input t plus 1 into the function, multiplied it all the way out and simplified, and ended up with the function of t plus 1 is equal to this polynomial.